This is a vintage Tatung color television, AM FM radio, like a hospitality TV. Motel, hotel, I don't know what you'd call it. So has an AM FM radio in it. Audio color. And you know, with a name like Tatung, you know it's gotta be good. I plug it in, I'll show you what it does. Of course, no picture, duh. This is gonna be impossible to find service data on. I might be able to find, there's some Tatung stuff listed in Sam's, but it's not gonna be this set with the AM FM radio. So, oh, by the way, I have two of these. They do exactly the same thing. That's radio FM. That's radio AM, and it's like the tuning string is broken if it has a string. And you put it on TV, and this lights up, but it just does nothing. Maybe the radio needs an antenna. I should check that. Let me see. But I'm curious to get inside of this. So if you put this on AM, but that might just be the tuner interfering, creating noise on AM. Let's open this. I'm just ready to absolutely just bask in the high quality mil spec design engineering components of the Tatung. VHF, UHF, and alarm. Now what I believe this was for, in a motel, hotel, if this got cut, it would set off an alarm and let the front desk know that you were taking the Tatung home with you. 1987 Tatung. So the alarm looks like it's just a, what is that, brown, black, brown, 100 ohm resistor. So I guess if that thing sees a short or an open and it doesn't see 100 ohms, it calls the police. This just looks like the cheapest of the cheap. Is that the tuner right there? Look at all these green capacitors in here. Elite brand. This is like terrifying. Here's the radio. How does that come out of there? And that's exactly it. You can see the tuning capacitor back here, right here. And the string is not moving that. Ooh, the string is broken. Crap. Let me try and get that module out. See, what's it take? TVA9240. Probably one of those all-in-one chips. It actually looks like this is the power transformer for it. See the two blue wires? Comes right up here, bridge rectifier, filter capacitor, regulator. 7809, 9 volt regulator, linear regulator. So it's a pretty nice add-on package, if you want to call it that. Let's so what What's broken here? What if I just put another turn around this? Actually, what holds that from popping off there? Is there a plastic thing that's broken here? Something's missing here. See how this has this little plastic hook right here? I bet there's supposed to be a plastic hook right there that's broken. Like I said, I have two that do exactly the same thing. This is like something General Electric would do. I mean, I kind of like the options here. We're getting both a radio and a TV video in one package. See?
You know what? With so many good places to go, maybe I'll listen to them all. Spoiler alert. Hey, what's up,
is still made of paper.
There's channel 6 analog. Okay, so the radio works. It's just the little hook that was here that held the wire broke off, like this one right here. So, I mean, we could probably drive a screw in there. I'll have to think about that. I can come up with something for that. Very, very cool idea. Very neat, modular kind of, very neat. I like it. I don't know why, but, you know, it seems like decent quality. Now, why does the TV not work? You know, that's the terrifying part, is the flyback shorted, horizontal output bad, bad capacitors. You know, this is one. This is one for our horizontal output tester. So that switch at the bottom is the TV FM switch, this switch right here. And our TV is just totally dead, I think. Okay, the relay there is clicking. Okay, let's do a few preliminary checks here. That fuse is good. Blown fuses in a TV of this era and this design are never a good thing. Crap, that one's open. So that fuse there, am I actually connected onto it? That one appears to have a bunch of voltage across it. Let's measure voltage. The meter goes negative when I connect to that. Yeah, that one's got negative 40 volts across it, and I'm unplugged. So that's never a good thing. Let's see. Let's see if our horizontal output transistor is shorted. We'll go from collector to emitter. It's not shorted that way. These have an internal damper diode. It's not shorted. So the fuse is blown, but the horizontal output is not shorted. Can't see. Okay, this is 1.25 amps. That's a 60 watt bulb I've got bridged in there. Now let's see what happens. Like I said, usually nothing good comes out of... Well, I heard the high voltage come up. Oh yeah. The high voltage came up. If I hang that there, can we actually see the high voltage? Will that like just demonstrate it? Nope. But it comes up for a split second, then it goes away, and there's a lot of current draw. See what our voltage drop across this bulb is. 98 volts and climbing. DC, so this is on the... This fuse probably supplies the horizontal output. I'm going to dig through the SAMs and see if I can find something close, maybe that for just the consumer market that covers the TV chassis close. And we're going to come back to this. This seems kind of cool. Back to our Tatung hotel radio television combination 19-inch tabletop set. I'm going to use a piece of equipment here you've never seen me use before. This is the Sencore TVA92, and this is a lot like, performs a lot of the sweep circuit test functions like that little handheld one I have, although this is supposed to be a lot better. This is the VG91 below that I use all the time that generates patterns. They go together. You can't have one without the other, because you can see the DB15 there that links them. The top one gets its sync signal from the bottom one. So unless you have the VG91, the TVA92 will not work. So we can plug into this. This thing will drive the sweep and measure the current, and we don't have to worry about batteries running down, etc. I believe this set was made in '86. I think that's what it said. And I went through the SAMs. The closest, or the latest Tatung that SAMs carried is 82. So a 19 CFB. So we're going to have to try and make do with that to fix that. And I believe I opened it up, and that chip is the same, the TA7644BP. I believe that's the same. In fact, I could open this and check that real quick. And it looks like they're not the same. This set uses a 7608. This set has a 7644. So they're kind of different. I don't know if this is going to do us any good. It's going to be difficult to fix this without any service data. It's going to kind of be luck, but we'll give it a shot. So first thing I need to do is I need to find where the B plus connects to the flyback. That's obviously the leg that connects to the collector of the output transistor. Now I'm looking at this and I'm like, wow, look at that. That's kind of cool. Someone drilled a trace out of the board. And of course nothing is labeled on this. I mean, the only thing I see labeled is down here where it says 134 volts. And that's like, oh well. Yeah, I need to find the B plus of the flyback. I guess I could do it with a meter. Okay, so just using an ohm meter from the collector. I get 1 ohm to 2 points here. I think one of them was here and this one. And I start following this. You see I marked it with red there. So I come to an inductor. Then if we follow that back, we come to here. Then we come to a jumper over to our 134 volt test point, which I marked with red. So this is obviously B plus right here. So 134 volts here to the jumper to here, and then follow this around to the little inductor to the flyback. So this is where our B plus comes into the flyback. Soldering all looks good on this. So this is saying 3 milliamps bad, and I'm checking this over and over. Maybe the TVA92 is bad. I mean, we know that this thing shoots up high voltage. I'm gonna get the little one. I was hoping to try something new here, but maybe this thing is screwed up. Okay, well, we hooked this one up and we get a little bit different picture. 6.8 microseconds indicates that the timing of the horizontal circuit is way off. That could be a bad capacitor or something. And yeah, we have too much of a load. So there's a bunch of secondary supplies that come off of these. You know, all the low voltage supplies, they're diodes that come off secondary windings. So let me think about how to go about troubleshooting this. But yeah, it's kind of a bummer this doesn't work, because I'd like to see that work. That way we don't have to deal with the batteries going dead in this thing constantly. So what we have here is a bunch of secondary windings, you know, the high voltage and focus on top. And then we have these secondary windings. Here's the grounds. You know, they'll come to a resistor, then they come through a resistor to a diode, then we get like 12 volts. You know, and they're all, you know, feeding these lovely green capacitors that are probably shorted. But what I'm thinking of doing is, maybe what I'll do first is I'll test the diodes with diode check and see if they're shorted. And then I'll start lifting these resistors and checking the current draw. Actually, before I do that, I have another one of these. It's brand new in the box. That's what happens when you clean out a bunch of TV shops as they go out of business. I'm gonna go grab that, and we'll see if I'm doing something wrong or if that thing is jacked up. Maybe we could repair that. Okay, so brand new out of the box. It still has that new electronics smell. 180 milliamps, so this one is definitely something wrong with it. So maybe we could repair this sometime in the future. Anyway, same thing, the horizontal is way too low, so that means the resonance is off. But what's interesting is I was measuring a bunch of these diodes, and this one here connected, I think this capacitor is measuring 0.1 volt drop. Should probably just let it run for a while and then take a look at it with a thermal camera and see what's getting hot, and we know right where the load is. This is driving the horizontal at 10% of its design peak to peak. So this thing would use 1.8 amps or more when you fire it up and blow something up. So we just don't know where the overload is. So the typical current on this should be 5 to 80 milliamps, and our resonant frequency should be 11.3 to 15 microseconds. So looking at our voltages here, and remember they should be they should be 10%. So on the 12 volt, we have 1.0 volts, and here we have 5 volts, so that would be about a 50 volt source. See, we don't know what these are supposed to be because we don't have a schematic. Well, I think what I might do is I might just start lifting these out, or maybe just start desoldering the pins of the flyback. I pulled these two out and we dropped to 177 milliamps. Still way too much. Taking a look at this with the thermal camera, I've been driving the 178 milliamps or whatever it is into this for a while, and I think it's pretty clear that the flyback is bad. We got some shorted turns in the flyback, obviously. Something right there is a little bit warm. But that resistor right there is a tad warm. We might want to lift that just to see, but obviously the flyback is, you know. And where would you, wow, the flyback is 180 degrees, huh? I didn't even notice that. Sure doesn't feel, it sure doesn't feel like 100 and, oh, I'm sorry, 80 degrees. Yeah, maybe. Yeah, we got a hot spot right there. Should probably lift that out and see what happens. But very, very obviously our flyback is bad. We could do a ring test on it. I removed that resistor that was slightly warm and the current draw went down like 4 milliamps. I'm going to pop the flyback off of here. I think the easiest way to do it is just to use the heat gun and heat it up with air, and just because it's it doesn't want to desolder too easy. I'm going to grab the heat gun and do that. This has got to be done with some care, because you can melt or burn or set fire to the whole thing, and you don't want to do that. I wish I could share that odor. That's something that's going to linger. So I'm on the primary, and I'm going to do the ringer test. Ten rings. 5 rings? Come on, make up your mind, dude. Like, how many rings do we have here? Like, do we have an Uber Eats driver in New York City number of rings? Or do we have a... Hey, you know what? I'm going to just drive the damn thing. So 109 milliamps out of circuit. So driving the flyback out of circuit, we have 108 milliamps. So it's got to have some shorted turns in it. You know, for experimental purposes, I think I'll see if I can find a flyback off of an EOLer and we'll check it. Okay, here's a flyback out of a set that got sacrificed here. And we get 18 rings. I think this can explain it a lot better than I can, so don't mind if I read this. The most common flyback failure is a shorted turn or turns. A failure can only be detected using the 92's ringer test. A flyback usually has several windings. Some of them contain just a few turns of wire and will not normally ring more than 10 times. Over here it talks about ringer test provides a fast, reliable way to check deflection yokes, flybacks, and switching transformers for shorted turns. Use a ringer test when possible, and these components are a shorted turn is very difficult to detect with any other method except the ringer test. Shorted turns can greatly alter the circuit's operation, but they may have little or no effect on the DC voltages and resistance values. A good yoke, flyback, or switching transformer will ring more than 10 times when tested, but a shorted turn will ring less than 10 times. And it talks about over here, it talks about removing it from the circuit. Flyback connected to the circuit, however, the components will often cause the flyback to ring bad in circuit. If the flyback rings bad when you test it in the circuit, disconnect the circuits that are most likely to cause a load to the ringer test. See, that's what we were doing by removing the resistors. Damper, diode, talk about removing all this stuff. Well, if the flyback still tests bad after you disconnected each of the above circuits, unsolder it completely and remove it from the circuit. If the flyback primary still rings less than 10 times, the flyback is bad and must be replaced. Flyback transformers can also develop two other common failures: leakage between windings and open windings. Well, you know, I'm just a little bit... My experience has generally been when a flyback goes bad that there's smoke and sometimes fire, and this thing obviously is only ringing 5 times, and the other one we had is ringing, what, 17 or 18 times. So, I mean, that pretty much condemns this flyback. You know, I'm almost tempted to check a couple of these capacitors, because these capacitors that go from collector to emitter, that kind of control the high voltage, especially this 330. Maybe I'll ring the yoke. Let's ring the yoke. That should be pretty easy. The yoke is only ringing 4 rings, so that, I can't believe the yoke is bad too. Not on something this new. I mean, I guess they can go, anything can go bad, but that's more likely it's got dampening resistors in it somewhere. See how this flyback has eyelets? This thing would be almost impossible to remove without a torch or without a way to heat all of these up at once. Trying to desolder that would be a real challenge with those eyelets in there. Okay, well, here's what I'm going to do. Check out the FM antenna coupled to the line cord. I'm going to grab another one of these sets. Like I said, they're hotel TVs, and the guy had a whole bunch of them. So I got 2 of them. So let's grab the other one, pull the back off, and compare what we got, since we got this lovely stack of equipment here. I yanked another one of these out of a old TV, and about the same era, and I got 30 rings on this one. Check out how sensitive this ring test is. This is just a roll of a connection hookup wire, right? I'm just going to stick this through. This is the core right here. I'm going to just stick that through like that, and I'm going to just bend it over and put one shorted turn here. Just one short turn. I'm just going to short this like this. So watch what happens here. Okay, we're at 30 rings, right? It's now shorted. See that? Unshorted. Okay, I'm going to short it again. That's shorted. Just that one shorted turn around the core cuts the rings in half. Let's try putting power to it and see what it does. Okay, now I'm feeding load test into it, and this is not shorted. So 27 milliamps on the resonant. This is the resonant frequency, which is not good because it doesn't have the rest of the circuit there. So this is our current. I'm going to short that. I'm going to short this. That doubles the current. One shorted turn. One shorted turn around the core kills it. Anyone know where to get a Tatung flyback? TFB 174A. I'm going to go grab the other set. I'm sure it's the same problem. Pattern problems. And we'll pull it apart and see what's up. Here's our next Tatung hotel TV audio color. And I don't know if this is going to show up on the camera, but it almost looks like the phosphor is delaminating off the... I don't know if that's going to show up on this. Oh, there it is a little bit. You can see all the little spots. So anyway, more of that Tatung quality. Audio color by Tatung. The symptoms of this one are exactly the same. Let's just assume it's the flyback. So we'll just open it up, check that fuse, get my hip hop on here, and we'll go from there. Well, this one looks like it has a different resistor on the alarm. This is like a 2.7K. Red, purple, yellow. This one looks like it has a different resistor on the alarm. Red, violet, red, so 2.7K. Well, this is interesting. This one definitely has a different flyback in it. It's been replaced. Obviously, you can tell by the flux on the board here. So, you know, as I suspected, this was probably a very common failure on these sets. So let's start. We'll check the fuse first. Look at this. This set has been unplugged for more than a week. And there's still 43 volts in that capacitor sitting across that fuse. So that fuse is blown just like the last one. Here's one difference on diode check. This horizontal output transistor is shorted emitter to collector. So that's one difference, but I would suggest that the flyback did something and took out the horizontal output transistor. Looking at this thing, you know, it's clean inside. EIA 577. I wonder who that is. I'm not even interested enough to take the time to look it up. You know, it seems like it's a decent idea. It's just junk. It's just not executed well. It's inferior parts, you know. But I like the idea of this. I just have a feeling these were just cheap junk with horrible reliability, even when they were new. So interesting. Looking on eBay, there are some TFBs. Maybe I can find a TFB 174. Is that just like a generic number for this type of flyback in this era? Okay, I did some research and it might be possible to find that flyback. It is a number in the cross-reference books. It's going to be difficult. I lifted the collector here. I pulled the collector lead out to get that shorted transistor, and I'm doing the same test, and on this one I've got 260 milliamps. So this one's really chomping away. I also noticed that on one of those secondary diodes, let's see, where is it? The solder looks really baked. Is it that one right there? Yeah, see that's failed solder joint there? I mean, that sucker's been running hot. So I'm going to just let this run for 10 minutes, 260 milliamps, you know, and then we'll take the thermal camera to it and just look at it. I'm going to do some research. I think this TFB number might be kind of a universal number, but then you get into all the junk counterfeit aftermarket flybacks. So what I'm doing is I'm just letting this thing cook for a few minutes at 250 milliamps, and then we'll take the thermal to it and see where the heat is. Okay, well, what's going on here? I don't see any heat at all. Is the flyback just like dead shorted, like 100% shorted? Let me drop this down a little bit. Drop it down a little bit more. So, I don't know. I see no heat here. So on this one, I'm getting the same thing if I connect the two leads together as if I'm connected to the flyback. I get the same thing. So it's like something is just totally shorted here. And I get the same thing as if I go from there to ground. So it's almost like either the flyback is 100% shorted or something else is shorted. And I'm trying to think of how to get the flyback out of circuit so we can isolate that. And I'm almost tempted just to take and cut the trace. What I've done is I lifted the capacitors. I lifted anything that was connected to this pin out. I lifted it. So I got this pulled, that pulled, and I got the yoke unplugged. And it's still measuring shorted. So this flyback is 100% shorted. It's like 0 ohms shorted. So this Taiwanese flyback is measuring 2 ohms to ground. That's out of the circuit. So it's internally shorted. The primary is internally shorted to ground. Not a lot of hope for Tatungs. Not a lot of hope. Just kind of a note, I don't think the yellow wire is making connection in the plug on this this one. Maybe I should open it real quick if I can. The test equipment far exceeds the value and build quality of the TV. Maybe that's the way it's supposed to be. Okay, well that's not the problem because I can come in here and check and all the wires are making contact to the board, so this would be a big disassembly job and I'm not going to dig into that today. This is a video on Tatung quality color television, not this American made garbage. We'll get back to this in a later date. So there's the saga of the Tatung AM/FM radio hotel hospitality sets from 1987. Unfortunately, the outcome is not good. I have I'm going to spend some time trying to find the flybacks, but with all the counterfeit Chinese junk that only lasts 2 hours if it works at all from the start, you know, the hope is not real high for these. There's better things I can spend my time on. as far as substituting something in there, time exceeds value of television. So that's, I guess, a quick and hard lesson in diagnosing horizontal circuits in mid-80s TVs. Usually the outcome's not going to be good. It's going to be, something where the high voltage potential is quite high, like the flyback. That's nothing new for a TV. That's, the breakdown point. That's where all the heat and power is, and that's where the failure point is. So, anyway, yeah.